Hi everyone, today we will discuss more problems as far as vectors and scalar this topic is concerned. So let us consider this question. Here we have a vector A, that is 3i plus j plus 4k, and another vector B, I plus 3j minus 5k. We have to find the unit vector in the direction of this vector A plus B as well as vector A minus B. Now let us first discuss a simple question, how to calculate the unit vector corresponding to any vector. So if you have suppose a vector A, let us consider this AI plus BJ plus CK. Suppose we have this vector. Now in this vector A, we have the magnitude as well as we have the direction. But we need a vector, or we want a vector, unit vector corresponding to this vector. So whatever be the magnitude of this vector A, we want a unit vector, means corresponding to A, means magnitude of that vector, it should be equal to 1, but the direction of that vector, it should remain same as the direction of this vector A. So it means our requirement is this unit vector A. It should be equal to the vector A divided by its magnitude. Suppose 5 meter east. 5 meter east is a vector, okay, because its magnitude is 5 meter, direction is it. Now you want a unit vector corresponding to this vector, so it should be equal to how much? 1 meter east. It means 5 meter east, that has to be divided by what? The magnitude of that vector. So here also, if we want a unit vector corresponding to this vector A, it means the magnitude of this vector, it should be equal to 1. Rest of the things remain same as this vector. And when we say rest of the things, it means mainly the direction of that vector. So here this is the vector A. It has its own direction as well as its magnitude. If we divide by the magnitude of this vector, then magnitude will become what? 1. 5 meter is divided by 5, it will become 1 meter. That's what we are doing. So you can write it as AI plus BJ plus CK, okay, divided by magnitude of the vector. So if this is your vector A, then the magnitude of the vector A, it will be equal to how much? Square root of A square plus B square plus C square. So square root of A square plus B square plus C square. This is the magnitude of the vector A. Now the total magnitude of this vector A, it has been divided by its magnitude. It means the remaining magnitude, it will be equal to 1 meter, 1, and corresponding to that, that gives you the concept of the unit vector, this A. So that way we calculate unit vector corresponding to any vector. Now here in this question, two vectors A and B are given. We have to calculate unit vector corresponding to A plus B as well as A minus B. So first we will calculate the value of vector A plus vector B. Similarly vector A minus B, using same concept, we will consider or calculate the unit vector corresponding to this as well as corresponding to this. So now you can see vector A plus B, if it is equal to suppose vector C, then C it is A plus B, that is 3i plus j plus 4k plus I plus j minus 5k. I will be added with I, j with j, k with k, simplify, and we are getting this. Now this is our vector C, which is equal to vector A plus B. So unit vector corresponding to C, it will be how much? Vector C divided by its magnitude. So vector C divided by magnitude. So we are getting this relation. Now here either you can write in this form, or we can separate I, j and k. So we can write it as 4 by root 33i plus 4 upon root 33j plus, and here it is minus of this. So minus of 1 divided by root 33k. So that way you can write. Either directly we could have written this minus of 1 upon root 33 or plus minus of 1 upon root 33k. So this way you can separate their coefficients and you can write it as I, j and k. So this is the unit vector corresponding to vector A plus B. Now similarly see this vector D, we are assuming vector A minus B. So again this is our A, this is B, A minus B, we are getting this. Again you have this unit vector D divided by its magnitude. Simplify this and again you can, so again you can write in this form, or if you want to separate it, it will be 2 upon square root of 89i minus 2 upon square root of 89j plus 9 upon square root of 89k. So that way we can represent it. Now see this question, we have to find the angle theta between these two vectors. Now here you see, here we have written it, this A and B are in bold. So in printed form, if you write the vectors in the printed form and if it is in bold, then there is no need to give that arrow mark here, that arrow representation for the vector. If this vector A, either you write this way or suppose A is bold, so then we don't need to put any representation. That also signifies that it is a vector. So here you can see A is bold and B is bold. So that's why we have not put this arrow here. Now these two vectors A and B are given. We have to find angle between them. So once we have to find angle between them, always try to use the dot product, because if you use the cross product, then there is again that unit vector n. So unnecessarily we will get into some complication. So it is better that we calculate the dot product, use this concept, get the value of cos theta, and once we get cos theta, from there we can calculate the value of theta. So A dot B, so let us first calculate this A dot B. So A is I plus 2j plus 3k, B is 2i plus 3j plus 5k. So A dot B, it will be how much? I dot I, so that becomes 1 into 2, 2, 2 into 3, 6, 3 into 5, that is 15. So 2 plus 6 plus 15, that is equal to 23. This you can observe. Cos theta, it will be equal to how much? A dot B divided by AB. When we say AB means mod of A into mod of B. So A dot B we have calculated 23, mod of A it is coming as the square root of 14, mod of A yani 1 square plus 2 square plus 3 square root. Here it is mod of B 2 square plus 3 square plus 5 square root. So that we are getting square root of 14, square root of 38. Once we have this relation, just simplify, you are getting this cos theta. So from here theta is equal to cos inverse 23 upon square root of 532. So that way we can calculate the angle between A and B. Means the logic or concept here is get the dot product, get the value of A dot B, get the value of mod of A into mod of B. Once you calculate this cos theta, it will be A dot B divided by mod of A mod of B. Substitute the values and calculate your angle. Now in this question, if you see, a particle moves 30 degrees north of east. So this is your direction. A particle moves 30 degrees north of east, means from east towards north 30 degrees. So this angle is 30 degrees. Now, with velocity 10 meter per second. So it is moving with 10 meter per second. We have to represent its velocity in the frame of reference having eastward direction as x-axis, and this is taken as x-axis, and northward direction as y-axis. So this is your y-axis. So we have to just resolute this velocity along x-axis as well as y-axis, means along eastward as well as y-ward. So in general, if this is suppose V and this is theta, then this component will be how much? V cos theta, and this component it will be V sin theta. This comes from the components of the vector or resolution of the vector. This angle is theta, so it is V cos theta, and this is V sin theta. So x component V cos 30 degree, because theta here it is 30 and V is 10. Simplifying, we are getting this, so it is coming as 5 root 3. And y component, that is the northward component, it will be either you say V sin 30 or we say V cos 60. Sin 30 it is same as cos 60. So this cos 60 here, it is same as this sin 30 degrees. So either way we can say, and this is coming as 5. So the velocity, if you want, so these are the components in the vector form, because we have to represent it vectorially. So in the vector form, that is equal to how much? AI plus Bj plus Ck, that is the general form as far as the vector representation is concerned. So here you can write V is equal to V1i or Vxi plus Vyj. Vx is known, that is 5 root 3, Vy is known, that is 5, simplify and you are getting this relation. This 5 has been taken common from this as well as from this, so this gives you root 3 plus 5j. So simplifying we are getting this. So this is the vector representation of the component of this velocity along x-axis, y-axis or along eastward or northward direction. Now, in this question, if you see, a particle suffers 3 displacement by 4 meter in the northward direction, 4 meter in the northward direction, 2 meter southeast. So if you consider this, so this is again your north, this is south, this is east and this is west. So 4 meter first in the north towards this, okay. 2 meters southeast. So this is east and this is south. So at this point again, if you consider the direction, this side it is east, this side, so southeast. So this will be southeast. When it is southeast, it means it is equally inclined to south as well as it is equally inclined to east. So this direction becomes how much? 45 degree. Okay. And 1 meter southwest. So again, once it comes here, 1 meter southwest. So this side again here, if you consider the direction, here again it is east, this is west, this is north and this is south. Southwest means again this way. Again this angle it will be how much? 45 degree. Okay. What is the displacement of the particle and what is the distance covered by it? So it means the particle has started from here 4 meter, then this side at an angle of 45 degree and again this side at an angle of 45 degree. It means final is what? This is the final displacement. It has started from this point and it has reached this. So this is the displacement that we have to calculate. Distance covered will be what? This plus this and plus this. So let us analyze this. So here you can see we are taking x-axis along eastward direction, y-axis along northward direction. So using that S1, if the displacement, first displacement is suppose S1, S1 is equal to how much? 4j, 4 meter towards north. North we are taking along y-axis. Y-axis means unit vector j. So that is considered as 4j. S2. S2 means this displacement, means 2 meter southwest. So this component will be how much? 2 cos 45 and this component it will be 2 sin 45. This is towards the right but this is towards negative of y-axis. So that will give you 2 cos 45i and minus 2 sin 45j because it is along negative of y-axis towards south. So towards south, so that becomes minus of 2 sin 45j. Then comes the third displacement, this one. So this is again what? Towards negative of x as well as towards negative of y. Yani towards west as well as towards south. Both will be negative. So it is minus of 2 cos 45i minus 2 sin 45j. Now again we will do this operation. So total displacement it will be how much? Or the net displacement it will be how much? S1. These are the vector sum because displacement it is a vector quantity. So these are the vector sums. So S1 plus S2 plus S3. So 4j, S1 was 4j plus root 2i minus root 2j, that was your S2, minus root 2i minus root 2j, that is S3. Now I will be added or subtracted with I, j with j and k with k. Simplifying that, we are getting magnitude of this. Once you calculate this S, After simplifying, you will get it as, suppose, AI plus Bj plus Ck, taking the three dimensional in general. If it is two dimensional, we will take it as AI plus Bj. Then magnitude of that will be how much? A square plus B square square root. Yani I component square plus J component square square root. That's what it has been done here once we calculate the magnitude. So it is coming as 4 minus 2 root 2. Finally, it is 1.17 meter. Direction, how to calculate the direction, why we have written this northward, because finally after simplifying this, if it is coming towards positive j or positive y, directly we will write northward. But in general, if the final direction makes angle alpha with the x-axis, then tan alpha it will be equal to how much? Y component divided by x. This is the general method, and always we should follow this. So y component divided by x component. Y here is what? J component. X will be your I component. Divide them and you will be able to get the value of alpha. So here finally we are getting this northward, because after simplifying, if you see this 2i and this root 2i, that gets cancelled, this and this gets cancelled. So this is your j, this is j, and this is j. So everything is only along j. J means y axis. So once the final displacement is along y axis, so directly we can say that it is in the northward direction. Then we can ignore this calculation, because it is already obvious that I component have been cancelled, only j component remains. So j component remains, it means it is along y axis. If it is positive, it will be towards north. If it is coming with the negative sign, it means it is towards south. So it is finally coming with the positive sign along the j, means along y. So finally we can say that it is in the northward direction. Now again, if you see this question, a train travels a distance of 5 km in the northeast direction, again northeast direction, at rate of 40 km per hour, and then distance 5 km at the rate of 40 km per hour in the southeast direction. What is the average speed? Just one second. In the previous question, if you see this, we were supposed to calculate distance also. The total distance described, it will be equal to how much? Because it is a scalar quantity, distance covered, so we don't have to get into the direction of each and every. So it was 4 meter, then it is 2 meter, and then it is 1 meter. So just ignoring this direction, we have to just add, because we have to just consider the distance, which is just the algebraic sum of all the distance covered. So 4 plus 2 plus 1, that is 7 meters. So this is distance covered, and this was your displacement of the particle in the northward direction. Now see this question. A train travels 5 km in the northeast direction at a rate of 40 km per hour, and then distance of 5 km at the rate of 40 km per hour in the southeast direction. What is the average speed during the whole journey, and what is the average velocity? Again, average speed means we will be talking of the scalar part, and average velocity we will be talking of the vector part of this. So the total time of travel will be how much? Train travels 5 km at a rate of 40 km per hour. So 5 km with 40. So time will be distance divided by this velocity. Here similarly, then 5 km with 40 again. So 5 by 40. So it is coming as 1 by 4 hour. The total time duration of this journey, it is coming as 1 by 4 hour. Total distance covered is how much? We are talking of the distance, not the displacement. So distance covered total is 5 km here, and again 5 km here, means the 10 km. So the average speed, it will be total distance covered with divided by total time taken. So that's why we have not considered the directions. We are right now calculating only the average speed. So the total distance covered divided by total time taken, that is the average speed. So simplifying, we are getting this relation. Now if you calculate the average velocity, so average velocity, so here we have to take care of the directions. Now here you can see this Rf minus Ri. So this Rf minus Ri, this is the position vector of the final displacement and minus position vector of the initial displacement. Ri means the initial displacement, this is the final displacement. So here if you again consider the eastward along the x-axis, northward along y-axis, taking the x-axis and y-axis as far as the east, west, north and south directions are concerned. So we can consider the first displacement as 5 root 5 I means along the x-axis minus 0 I in the sense there is no displacement as far as the second displacement is concerned along the x-axis. That's why that magnitude part it has been taken as 0. So it is 5 root 5 I. So average velocity it will be how much? Net displacement divided by total time taken, and net displacement it is coming as 5 root 5 divided by 1 by 4. So it is 20 root 5 I. When we say this average velocity, so again velocity will have some direction. So here we are getting this unit vector I. It means the velocity it is along what? Positive x-axis, because here the sign is also positive. So 20 root 5 along the positive x-axis or along the eastward direction. So its average velocity is 20 root 5 kilometer per hour towards the east direction. That conclusion we are getting from here. You can again just see this 5 kilometer in the northeast direction, 5 kilometer towards the northeast direction, and at a rate of 40 kilometer, and then 5 kilometer at the rate of 40 kilometer in the southeast direction. So what is the component of this 5 kilometer? So 5 kilometer along southeast direction and 5 kilometer in the northeast direction. So you can see this north and this south, they have cancelled each other, and that's why here you can see this as 0. This part it is 0. So it is 5 root 5 I minus this 0j, and finally it is coming as 5 root 5 I. So after simplifying we are getting this 20 root 5 kilometer per hour towards the east direction. So we have solved some of the questions, and we will solve more and more questions as far as this topic is concerned. Thank you.